Okay, this video is going to be on the alternating series estimation theorem. And what this is all about, in most of the tests for convergence or divergence, you're able to find out whether the series converges or diverges. But in most cases, you can't figure out the sum that it converges to. Now, there's a couple of exceptions to that. You might remember if it's a geometric series, then you can use R to figure out whether it's converging or diverging. And there was a formula for a geometric series that allow you to quickly find the sum. But in most cases, that's not true. So if you're given a series and you know it converges, if you want to get an estimate of the sum, the best way to do it is to just sum up a certain number of partial sums, and that partial sum will give you an estimate of what the actual sum would be. But whenever you're working with an alternating series test, it has a couple of special cases, and the rule looks like this. Let's take a look at just kind of what the rule means. It says S minus S sub n is equal to the absolute value of R, which is less than or equal to A sub n plus 1. Now, that doesn't give you much help on what's going on, but I think if you rewrite it, this actually turns out to be a pretty easy rule to understand and to use. So what happens is S is the actual sum of the series, S sub n is the partial sum, and R is the remainder. So what it says is, and this should make sense, the difference between the actual sum and the partial sum gives you the remainder. Now, I prefer to write it out. I think I'll write it out like this. Rather than having S sub n on this side, I'm going to move S sub n to this other side, and it'll actually wind up looking like this. I'll have the sum, and I'll put the sum right here. So the sum is equal to, and take this negative S sub n, move it over here and make it be a positive S sub n. So S sub n, that's the partial sum, and then I'm actually going to have plus or minus the remainder. So maybe it can go up a little bit, or maybe it can go down a little bit. Let's draw a picture and see what this looks like. So the idea, first of all, you get to pick how many terms you want to sum up. So just for this example, let's suppose we do this. I'm going to let n be equal to 4. Now what that does, it kind of divides it up between here and here, and it divides the graph into two parts. If I sum up the first 4 terms, then the part over here would be represented by S sub n. That's going to be the sum of the first 4 terms. But the actual sum consists of the sum of the first 4 terms plus all these other terms. And all these other terms considered together are what's called the remainder. So it should make sense that the actual sum will consist of this partial sum plus or minus the remainder. It could be positive or negative. But now what is this remainder? And this is where it's kind of a cool trick on the alternating series if it's a convergent series. And it says this, that you want to know what are the sum of all of these remaining terms. And the sum of all the remaining terms, if it's an alternating geometric series, turns out to be this. So if you picked n, then the next term in the series would be this n plus 1, and as it turns out, the sum of all the remaining terms in the remainder will be less than or equal to this next term, this a sub 5 term. So that's what this actually means right here. The total remainder is going to be less than the next term. So this would be a sub n plus 1. So this is kind of what it looks like. Now I think if you write it in words, to me this makes a little bit more sense. I call it, this is going to be the sum of the first n terms. So you get to pick n, S sub n, you're going to sum them up. Then you're going to add to that, plus or minus. All you have to worry about is what I call the next term. So let's think of it. If you think of it like this, this is what you're actually doing, and it makes a lot more sense than the formula. So if you want to get the actual sum, it's the partial sum of the first n terms, plus or minus, and the biggest the remainder can be is whatever that next term is. So it's almost like you can forget about the 6th term and the 7th term and the 8th term. Don't worry about any of these. All these together have to be less than this 5th term. So you can represent the actual term as the sum on this side plus just this term, and you're done. So now, that's what it looks like. So let's take a look and see what a problem would be. Okay, now we're going to look at this problem, and we'll try to get an estimate of the sum, and hopefully you guys will recognize this is an alternating, actually it's an alternating harmonic series. Now you can't use this test unless the series does 2 things. It has to alternate and it has to converge. And you can use the alternating series test to show that Indeed, this alternating harmonic series is one we've done before, and it definitely is alternating, and it definitely converges. So what I'd like to do is to get an estimate of the sum of this thing, but let's solve it 2 ways. First of all, let's use the first 5 terms, then let's use the first 8 terms. Now, hopefully it would make sense to you. The more terms you use, the more accurate the answer should be, but let's just see how it works out. Now, again, I'll go back to this. For most students, this is kind of confusing if it's in this form because it doesn't really show you what to do or in what order. So let's write it down as a series of steps and see what that looks like. So for these type problems, I think you can put them in this step, series of steps to get to the answer. Now, real quickly on this graph, let's just quickly do just a generic case to show you how it works. So the idea is, first of all, make sure that the series that you're working with is alternating and convergent, and we've done that. Now, you get to pick a test in, and it's just however many terms you want to sum up. So for this generic case, let's suppose we did this. Let's pick n would be equal to, and I'll put it right here at 4. So I'm going to pick n is equal to 4. Now, I like to do this. I like to just draw a line on this thing just to remind me that I've actually kind of divided it up into 2 parts. So if I'm going to sum up the first 4 terms, then everything on this side is going to represent S sub 4, or S sub n, the sum of the first 4 terms. And just to give this example a number, let's suppose we did this and it turned out to be equal to 0.6. So it turns out to be 0.6 right here. That's going to be S sub n. Now I'll put, and I think I'll just kind of use a blue line here. That means that if I go from here over to right here, that the sum of this thing is approaching it. So maybe the points, it could be up here, down, up, down, but eventually they are approaching 0.6. So if you just summed up the first 4 terms, that you would get this. But now, from 0.6, it could go up a little bit or down a little bit, and it probably will as you add in all these additional terms. So the question is, how much does it go up or down? So it's based on this. It's going to be, the actual sum is going to be the sum of the first 4 terms plus the remainder. But what is the remainder? Well, that's where this comes in. So let's go back again. And I stopped with n equal to 4. So I can get the entire remainder by just looking at the what I'm going to call the next term. So the next term, if n plus 1, would be the 5th term. So I just need to evaluate a sub 5. So if I sum up the first 4 terms, all of the remainder can be no more than the next term, which is the 5th term. And let's just suppose that when you did this, again, you'll put these on your calculator. When you got this sum, you could just add them up on your calculator. If you want to know what the 5th term is, just plug a 5 in for n, evaluate that term, and suppose it turned out to be 0.1, just to give it a number. So what this means is, starting with S sub n is 0.6, the most that can happen is that it can go up by plus or minus 0.1. Now graphically what it looks like is this. You're at 0.6 right here. If you go way off here, possibly the sum can go up a little bit or it could go down a little bit, but it has to stay within a certain range. And what this does, this A sub n term lets you know how the maximum that it can go up or the maximum it can go down. So in this case, the most it could go up would be 0.1. The most it could go down is also 0.1. So that gives you, kind of put a dotted line here, this is the biggest that the actual sum can be. If you go down 1, this right here is the smallest that the actual sum can be. And this range in here gives you the range of the answer. So this would be the maximum it could be, and this is going to be the minimum it could be. So what that does, now you can actually figure out what that range is. So starting with this, if you took 0.6 minus 0.1, that would be this. So you want to find the actual sum. So the partial sum is this, minus the remainder, and you could have the partial sum plus the remainder. So if you did this one, you would get 0.5 is less than, and this is going to be the actual sum, and it's going to be less than, this one's going to be 0.7. So it actually turns out to be this right here. Now what that means is, if you started at 0.6 and you went up 1, the biggest this thing could be would be 0.7. If you started at 0.6 and went down 0.1, the smallest it could be is 0.5. So your actual sum has to fall somewhere in that range, and it gives you an idea. If you used 4 terms, then you can get an estimate of the answer to be somewhere between 0.5 and 0.7. So it's a good starting point. So now with that in mind, let's go ahead and actually work out a problem. So we'll remove all this and go back. And this is the problem that we're going to work, but we're going to do it 2 different ways. So first of all, in the first case, let's assume we use 5 terms. Second case, let's assume we use 8 terms. And what that would be, that's going to be step 1. So we can cross off step 1. We've picked a convenient n. Now, again, you don't have to do this, but I always like to draw kind of a sketch of it. So I'm going to go there. If I've got n is equal to 5, that's going to be n right there on this one. That actually kind of divides it up into 2 intervals. So say from here to here. Then on this one, if I let n equals to 8, I'll be down here at 8, and it's going to go from this to this. So what will happen? When I add these up, everything over here is going to give me the sum of the first 5 terms. Everything on this side is going to give me the sum of the first 8 terms. Okay, now the next step, let's go back and look at our steps again. So you picked a convenient n. So what you want to do next is go ahead and just on your calculator, if you need to, just evaluate, sum up the first 5 terms of the series or the first 8 terms. So just stick that on your calculator and see what you get. And when I did that, what I came up with is this, is the sum of the first 5 terms was I got 7833. So what that means is, and I'll kind of go over here and do it on this one, I had 0.78, which is about right here. So that means if you add up the first 5 terms of this, it'll go, say, from here over to about right here. So at 0.78, and it's going to go to right there. So this is going to be 0.78. Now the dots could look something, they could go up, down, they might look something like that, but they're settling in on 0.78. Then let's do the same thing on this problem. If I added up the first 8 terms, and I did this on my calculator, I came up with 0.6345. So what that means, 0.63, and again, we'll do it in blue here. This will be about 0.63 is about right there. And that means the sum of the first 8 terms tends to be approaching this blue line, which would be here. This is about 0.63. Now again, maybe they go up, down, but eventually they're settling on this point right here. So this is approximately what the sum is. And notice you got 2 different answers. If you use 5 terms, it says it's going to be somewhere around 0.78. If you use 8 terms, it's going to be around 0.63. Now, there's a range in which these things are valid. So the idea is if you add all these additional terms, it means this answer might go up a little bit, might go down a little bit. If you add all these additional terms, this answer might go up or down, but by how much? And that's where the remainder comes in. So let's take up the next term. Okay, so the next thing says this: evaluate the next term to see what the biggest the remainder could possibly be. So what that's going to be is if n is equal to 5, like on this one, if n is equal to 5, n plus 1 is going to be the 6th term. So all you have to do is to evaluate the 6th term, and that will tell you about all these other things together. So the next thing is to find a sub 6, the next term. And again, to find this, just take this formula, plug a 6 in for n, and when you do that, I came up with this, a negative 0.1667. So the 6th term of this one is going to be this. Now let's do the same thing down here. If, in this case, if you had n equal 8, then the n plus 1 term would be 9. So in this problem, I'm going to find the 9th term, and what that's going to give me is the magnitude of the remainder of all the remaining terms. So again, go back, just in place of n, plug in a 9, and when you do it this turn, turned out to be 0.1111. Okay, so now I've got this partial sum and the next term for each one of these. So now I want to know is what's the range of the actual sum. So we go back up, we've done the first step, done the second step, done the third step. Now the fourth step says this: the actual sum has to be equal to the partial sum plus or minus whatever the remainder is. So let's do that in both these cases. We'll go here, and we're going to say that the actual sum has to be the partial sum. So this is going to be s sub 5 plus or minus a sub 6. This one would have to be the partial sum of the first 8 terms plus or minus the 9th term. So it's going to look like that. So what that's going to be, let's go ahead and put these in. S sub 5 is 0.7833, and I'm going to have plus or minus. Now here's a little trick on this remainder. Depending on the term, it could be positive, it could be negative. You're going to add a plus or minus. So really, for all practical purposes, what you're doing here, you're taking the absolute value of this and the absolute value of this. So you can think of a sub 6 as being equal to, always put a positive because you're going to add plus or minus anyway. So this would be like 0.1667. Now, let's just stop right here and say, graphically, what does that mean? What this means is, starting from here, that the biggest this thing can do is to go up 0.1667, or starting from here, it could go down 1667. And that's going to give you a top boundary, and it's going to give you a bottom boundary. Okay, let's do the same thing down here. Starting with 0.6345, I'll add plus or minus 0.1111. So what that would mean is, starting at this, the most it can go up or down is 0.11. This would go up to maybe, so 0.1111 there, and it could possibly go down 0.1111 there. So here's the top of the possible actual sum, and here's the bottom. So the sum has to fall somewhere in this range. So let's continue on. You want to know what that range is. So the next thing, you've got this. So the actual sum has to be the partial sum minus the remainder, or the partial sum plus the remainder. It has to fall in that range. So we'll write this as the actual sum has to be, actually, it has to be from 0.7833 minus 0.1667 to 0.7833 plus 0.1667. Now, if you put these on a calculator, if you put this one together, it turned out to be 0.6166, and that has to be less than or equal to the actual sum, and again, we'll put actual sum here, which has to be less than or equal to, if you added these two together, I got 0.9500. So 9500. Now what that means, this number right here tells you that that height right there is 0.9500. This one right here is 0.6166, and you know that your actual sum has to fall somewhere in that range. So this is the answer to the first problem. So if you let n equal to 5, you can estimate the sum as being somewhere between here and here. Let's do the same thing down here. Let's take, this would be like having the actual sum. Now, first of all, if you take this minus this would be 0.6345 minus 0.1111, and this would be 0.6345 plus 0.1111. Now, if you put this one together, you would get 0.5234, and that has to be less than or equal to the actual sum, which is less than or equal to, and this would be 0.7456. So if you used 8 terms, you can estimate the actual sum to be somewhere in this range. So again, what this one would be, this is going to be, the lower part of this would be 0.5234, and the upper part would be 0.7456. And the actual sum has to fall somewhere in that range. Okay, now one thing that should show you out, it looks like, first of all, that they're kind of random, and actually they're not. If you use 5 terms, and notice the difference between these two from here to here, let's just round off a bit, 3.5 or about 0.4. So actually you had a pretty wide range here of about 0.4 from here to here. But on this one, you're going from 0.52 to 0.72. The range between these is about 0.2, so this is 0.2. So actually what this means is, when you come down here, these lines are getting closer together. The farther you go off to the right, the smaller the gap between the top and the bottom, which narrows in the accuracy of the answer. Now, finally, if you actually did this thing and took it all the way out to infinity, it's about equal to about 0.693. Now notice, in both cases, this is the actual answer. So in both cases, the actual answer does fall in the range, and it falls into this range. But it's just this range is smaller, so you can actually wind up a little bit more accurate answer. So this would be the preferred answer. So the idea is, if you want a more accurate answer, just use more terms. But if you just go back, and again, the rule itself is a little bit confusing, but it really just says that the actual sum is equal to the partial sum that you pick plus or minus any remainder. And the remainder can always be estimated by the next term. And then if you just remember this series of steps and follow this series of steps, the actual computation of it's really pretty easy. We'll go back and, again, it's just given the initial term, find the sum of the first n terms, find the remainder, and then just the actual sum is equal to the partial sum plus or minus the remainder. So that's a quick look at the alternating series test to estimate what the sum is.